Is this big enough for everybody? You guys in the back, do you want me to make this a tad bigger? It's good? All right. All right, so like I said, today I'm going to go over 2 problems at the beginning. I'll usually do this every class, and I'll do the same thing. I'll post in the Slack, and you guys can vote on which ones you want to see. I don't care which ones I do. You tell me, whatever. So the first one I'll do is my index of, okay? I think this question is actually not too bad. The only difficult part is, in my opinion, for beginners, is where to start the loop, right? And where to stop it. It can be tough. So, first things first, I'm going to write a function like this, okay? Const my index of, I'm going to set that equal to open close parentheses, and then a fat arrow, and then curly braces. This is a valid way of writing a function. Get used to seeing this, okay? Now, this function is going to take 3 things. It's going to take the string that we're looking through, the thing we're looking for, and where to start. But the thing is that where to start is an optional argument, okay? If you guys did a little bit of reading, I don't know how you would know this on your own, but there is an actual property of strings in JavaScript called index of. You just write any string and you say, okay, here's the string, dot index of, and then you just pass in what you're looking for and a starting point if you want. So we're basically creating that function here, okay? So we can do a source, we can do a search value, and we can do a start, okay? Now, let me just clear something up for you guys. Just some lingo, okay? There's 2 different words, okay? Parameters and arguments. When you're writing a function definition and you're referring to these things, these are parameters, okay? When you're calling a function and throwing things into the function, those things that you're throwing into it are arguments, okay? So here is where we talk about parameters, and when we're invoking functions, we refer to them as arguments, all right? Now, let's say I pass in one thing. If you pass in one thing to this function, my index of, that will always be captured by source. If you pass in 2 things, the second thing will always be captured by search value. And I said that this thing is optional, so I don't have to pass in a 3rd thing. If I don't pass in a 3rd thing, start, when referred to in here, is going to always be undefined. Every time. When you're defining your function, and you call it later, and you don't pass in something that the function might be looking for, these variables will still be read over here, but their value will be undefined. Okay. So there's a way around this. We can write an if statement. If start is equal to undefined, we can say start equals what? Where do we want to start if we don't tell it where to start? At the beginning, right? And what is the first index? 0, right? So we could say start equals 0. If we don't pass start in, start's just going to be 0. Then everything else that we're going to write, we will always have a value for start, whether we pass something in or we set it ourselves if nothing was passed in, okay? Now, you can do this, but my favorite way to do this is that. This is ES6, okay? When you're defining the function and you're writing the parameter, if you say the parameter's name and then you say one equal sign and then a value, JavaScript knows that if nothing is passed in to this function in this place, it will automatically be assigned 0. Is everyone following me on that? That's just a thing that is with the language of JavaScript, okay? This is a lot neater than writing an if statement, right? I just saved 3 lines of code. Is everyone with me? Sick. All right. So now, what is the purpose of index of? We have to return an index of where this search value will be, where it starts in the source, if it's there. And if it's not, we return -1, right? So, it looks like we're going to have to, since this is a string, we're going to have to loop through the source, right? We're going to have to check each one and look for the search value. And once we find that search value, we can just return the index. We can return I in the for loop. And if it's not there, and we loop through the whole thing and we never find it, we can return -1. That is the basic logic behind this problem, okay? So, I start writing my for loop by doing the basic structure. I like to do this, and I recommend you doing this too, okay? To just write for the open close parentheses and the open close curly braces to get your structure so you don't miss any curly braces later on, okay? The same thing with if statements too, okay? Just since you guys are beginners, it will just help you, okay? Yeah.
Sorry, to go backwards, but now you have source, search value, start. What if you wrote search value, source, start? I mean, does it matter? Why did you select that order?
The first thing that is going to be put into this function is going to be the string that we're going to be looking through. If I switch these around, then search value will actually be that string. It doesn't matter what I call it. See, I chose to call it this because I know the second thing that goes into this function will always be the thing we're looking for, right? So like this is source string, right? So this is the source string that we will be looking for every time. That's the function that we're required to write, okay? They just say, listen, you're never going to have to write a function where they might switch the parameters on you. You know, they might pass it in different places, okay? Usually. I don't think I've ever even done that. Does that make sense?
Yeah, and then it always goes source string, search value, start, or whatever your parameters are in there, only because that's the order in which they're in, right?
What do you mean?
Well, you said earlier that the first thing it'll check is source string, the second thing.
Yeah, like if I were to call my index of, right? And I just passed it in hello. I just passed in one thing. That will be source string. Because it is the first parameter in my function definition. If I just passed in one thing, that will be source string every time. Then search, in this case, for what I've written so far, search value will be undefined. But start will be 0. Does that make sense?
Yeah, because you're telling start.
Exactly. But I'm not telling search value to be anything. So in this case, search value will be undefined. But if I did this, I'm looking for a 0 in hello. Search value is now this string of 0. Does it make sense? And so on and so forth. No problem. So, we're going to set let I equal to what? Why? Is it? What if the start? Not 0. It is very easy to go into autopilot and just write a for loop where it say let I equal 0. Because usually you will be starting from the beginning of something and looping through the end. Usually. However, that is not the case in this problem. We want to start where whoever's calling this function tells it to start. Okay? In this case, we're saying start will be 0 if I don't give it a start value. So we can always reference start here, like so. Does that make sense? Right? Now, why am I doing this? I could honestly do this. It's fine. But why would I do this? Yeah.
Because at a certain point there won't be enough characters.
Exactly. If I'm searching for if I'm searching hello and I'm looking for tree, no, that's stupid. If I was looking for whatever, this is 4 characters, right? And this is 4 characters, this is 5 characters. A length of 5, a length of 4, right? I'm looking in this string for this entire thing in order, in sequence, right? I look in this character, it's an H, not an O, so we know that it's not here, right? So we go over here. This is an E, it's not an O, so we know that that can't be starting at here. There's only 3 characters left, and this is 4 characters. So we can just stop the loop, because we know that this is not in there anymore, right? Once there's a certain number of characters left in the thing we're looking through, we know that we can just stop it because this thing exceeds that count. Does that make sense? Right? Why bother looking if we know for a fact it can't be there? There's not enough room. Right? So, we can say if search value is triple equal to source string dot slice, and we're going to start it at I, and we're going to go to I plus search value dot length, we will return I. This is valid syntax. When you're writing it, before I get into what's going on inside the conditional, when you're writing if statements, if what goes in the curly braces is only one line, you can actually omit the curly braces and just put it right after, like that, like so, okay? This is shorthand, okay? So, what exactly, that's just like a fun fact. Now, let's see what's going on inside of the if statement, right? The thing we're looking for, the search value. If search value is equal to, well, I guess it makes more logical sense to put this back here. So, okay. So first we're saying sort. Is everyone familiar with the slice method? Okay. So the slice method is a string method, and it's also an array method. But we'll talk about arrays next week, so don't worry about that. So basically, if I was to say console.log, here, I'll just show you an example. It's easier to see. Console.log hello.slice, we're going to start at index 1 and go until index 3. Oh. And we get L. Slice is actually a built-in JavaScript method that you can use at any point in time. JavaScript supplies this for you. When you use it off a string, it takes a few arguments, okay? The first argument is the index in the string at where to start. And it's inclusive, okay? Remember that. The first argument is inclusive, okay? As you can see, we're starting at index 1 in hello, in the E, and it's here on the screen. The next point is where to stop, but we're not including the element at that index, right? At index 3, 0, 1, 2, 3 is actually the second L, but we're not including that, okay? The first index is inclusive, the second index is exclusive, okay? And if you pass in no arguments, you just get the whole thing. All right. So, we're saying, but that's a good way to grab a chunk of that source string out, right? Because we don't know what the search value is. Yeah, it could be one letter, and you don't have to do this at all. But it could be multiple letters. It could be multiple indexes. So, we know that we can grab a chunk off of that with slice by starting at wherever we are in the loop. Wherever we are in the loop, we'd be starting at the E if I was 1, right? So we'd start at 1, it would be including the E, and it'd go until the index of however long this is, right? So I plus the length of the search value. And we know we can do the search value's length and not length minus 1 because indexes are 1 off because the second argument is not inclusive, okay? So this right here will give us a chunk of the length of the search value from wherever we are in the loop. If that chunk is equal to the search value, we just return the index. That's where it starts, and that's what we got. And we'll do this until this statement, the second statement, is no longer true. So if we do that, then we break out of the loop and we can continue the function and we can just return -1. Because we know we looped through the whole thing, we looked for this thing, and it's not there. So we just return -1 because there is no -1 index. Indexes start at 0. Does that make sense? Is anyone confused? Yeah.
Can you explain exclusive? But I know you said inclusive.
Yeah. So the first argument in slice well, the two arguments in slice are indexes, right? They're numbers, but they're actually indexes. We're telling it where to start and where to stop. The start, the first point, is inclusive, meaning the element that is at index 1 will be included in the result, right? Index 1 at hello is E, and you get E here.
Right.
But the stop index is not inclusive. At index 3 is the second L, right? But that's not here. So it's everything before that index. That's what I mean by inclusive and exclusive, and not inclusive.
So to get O, you would have to put
To get the O?
or hello, you put O in 5.
Is that right? Yeah. It just goes to the end.
Okay.
Yeah.
In the if statement, the slice thing,
Yeah.
do you not do search value length -1 because of the exclusivity?
Yes.
Okay.
Because the length of this is 4, right? But index 4, if you try to access like an index of a string that doesn't exist, like if I did this thing at index 10, it would be undefined, right? But, so we know we don't want that undefined value, but this is an exclusive thing because this is 4, the length is 4, but the last index is 3, so it's not inclusive, so we'll get to the 3, right? Yeah.
Sort of related. You have the const there.
Where?
Right at the beginning.
Yeah.
The example solution doesn't have the const. Now it says define a function. Does that mean you need the const in there, or is that more of a declare the function? I'm kind of confused as to why you have the const in the sample.
There are two ways to write a function, right? They're not exactly the same thing. Even behind the scenes, they're not exactly the same thing. Here, what this is, I'm defining a variable that's called myIndexOf. And I'm assigning it an anonymous function with no name. The same thing would be this, const that's the same thing as that. That's exactly the same thing as that. But you can also just do function myIndexOf. And you could do that. It's the same result, but they're a little different. Defining functions in the global scope using the function keyword is different than assigning it to a variable. And you guys will learn about the difference when we talk about hoisting, okay? But it's essentially the same thing. I'm still defining a function here. Any other questions before we do the next problem that you guys wanted to see? Is everyone okay on this? Did me going over that help you? Okay. What is the next one? Ah, the most vowels. So, wasting no time at all, here is a function that's called most vowels, okay? I'm defining it the same way I did before. Const most vowels is equal to an anonymous function. And that anonymous function takes one argument, one parameter, and that parameter is called sentence, okay? So, what we want to do in this situation is we're going to have one string, but it's going to be a sentence, okay? And so there's going to be multiple words divided by spaces, okay? And we're going to have to see which word in that string has the most vowels. And this is a pain in the ass. It's a pain, right? It sucks. So, let's get to work. So, obviously, we have to loop through the sentence, right? Let's just break this down to like a mental one. We have to loop through the sentence. But how do we know if it's one value, right? It's one string. How do we know where a word starts and stops? I can't hear you. Spaces, right? We know that if a character that we're at is currently, like in the loop, is currently a space, we know everything before that was a word, right? So, we can capture that word, put it into a variable, then we can count all of the vowels in that word. Then we can put that count into another variable. Then we can continue looping, but we can reset that variable. This is a very common pattern of things. Storing a current something, comparing it against something we stored before, and then resetting the current variable, that current something. This is a very common pattern, and it's very powerful, okay? Because then we can always keep track systematically of whatever we're looking at, comparing it to something that we have stored in a variable somewhere else, and then at the end, we can return the thing that we had stored. I might not have explained that correct, in the best way, but let me show you what I'm talking about. So I said that we can have a current word element, a variable, and this is going to be used for storing the current word we have in our for loop, okay? What we're looking at right now, okay? Then we can say let current count, and we could set that equal to 0. That will be the count of vowels in this word, okay? Right now it's nothing, and the word is nothing, okay? And we will be comparing this against the max word. Well, no, we will be comparing the current count against the max count. The max count, if current count is ever greater than max count, we're going to say max count is now equal to the current count. So now max count will have that number, and then we can reset current count back to 0 for the next word. Does everyone kind of see like what I'm getting at now? But we don't care about the count, we care about the word. So if that is ever true, if current count is actually bigger than max count, then we know the max word would then be equal to the current word. Does that make sense? I haven't done anything yet except to find these variables though, okay? So if you didn't understand what I said, let's put this into code, right? So we say let I is equal to 0. This time we do start at 0. And we want to loop through the entire sentence, right? So I is less than sentence dot length. And we'll increase I every time. So this is kind of like a different way of thinking, in my opinion. Like, I wouldn't think of like solving a real problem in like my everyday life like this, but writing the part that happens when we come across a space first is actually easier to read, okay, in code. So we can decide what to do once we hit a space, or if we're at the end of the sentence first. Because that is when we will be reassigning variables. Because we know that if we're not at a space and we're not at the end of the sentence, there's only one place we can be. In the middle of a word, right? And what do we do at the middle of a word? We're just gonna put that letter into the current word, and that's all we're gonna do. This logic is more complex, so we'll write it first, okay? So we're gonna say if sentence at I wait, actually no, we'll do this first. Is not equal to a space, and I is not equal to the sentence dot length minus 1, so we're not at the last thing. We will do current word plus equals sentence at I. Sorry, I explained that wrong. We want to do this so when we're at sentence at I, we will have that current word first, okay? We'll have that letter in current word first. That's the first thing we want to do. We want to put it in there first, okay? Then we can say if, okay, so now what we want to do is we want to check and see if this letter is a vowel. Now, I think that people often struggle with knowing when is the best time to write a helper function, okay? I think that the best time to write a helper function is when you're looking at a problem that you're trying to solve and saying, oh, I have to write this like 6 lines of code, and it's a pain in the ass, and I don't want to think about it. When you think that, just take it out of the function and make another function, okay? That's actually, in my opinion, easier to reason about. And that pain in the ass thing is just checking if this letter is a vowel, okay? That's like kind of annoying. And it's gonna make, and it's a decent amount of code lines, so it's gonna make this function look more annoying than it actually is. It makes it harder to read, okay? And since that's like, we're checking to see if it's a vowel, we can, like in your head, you're kind of imagining, okay, so I have to check one specific thing, and I need a true or false statement out of that, right? It is a vowel or it isn't a vowel, true or false. So that just sounds like a function, right? So we can actually take that out and put it in another function outside. I'll write a function like this, and I'll call it isVal. And it's going to take a letter, right? A single letter. So now, let's just focus on writing this function first. First thing I'm going to do is I'm going to define a variable called vowels. A-E-I-O-U. Right? So now I'm going to say, we could do another loop here, but I'm lazy and I'm not going to do that because JavaScript has a lot of built-in methods that you can use. So I'm going to do if vowels dot includes letter. Dot includes is a method for strings. It's going to look in here and it's going to return true if this letter is inside of that. And just to be safe, since it's a sentence and some things are capitalized, we will just make everything lowercase, right? Or we can also put a, e, I, o, u in uppercase here. Because uppercase and lowercase words have different character codes. They're different values entirely. But I'll just do it like this. Letter dot to lowercase. Whatever that letter is, we're going to make it into a lowercase character, and then we're going to look inside vowels and see if it's there. If it is there, if this is true, we will return true. Otherwise, we will return false. I'll just write this out more clear for you guys. Okay? So if this is this, return true. Function stops. Otherwise, return false. Right? Right? This will let us know if something is a vowel or not. So back up here, we put that current letter into the current word. Now, since we know we're not at a space or the end of the sentence, we're keeping a count of vowels, right? So we can say if is vowel, invoke it, and pass in sentence of I, that letter we just put in here, we can say current count plus plus. Plus plus is shorthand for plus equals 1. Oh, whoops. Okay? And plus equals 1 is shorthand for equals current count plus 1. Whatever the current count was, plus 1, is now what current count will be. Okay? But an easier way to write this is just plus plus. And we don't need an else statement, right? Else do nothing. Continue the loop. We don't care if it's a consonant, right? Have I lost anybody yet? Are you sure? Any questions? Does everyone agree that in this loop, that all I've written so far, we will look through it, and if it's not a space, we will add it to the current word, and we check if it's a vowel, and if it is, we'll increase the count by 1, right? That is all that this is doing right now, right? Does anyone disagree with me? All right. So now, we will write our else statement. The else statement will be if, basically, it is a space, or it is the end of the sentence. The end of sentences are periods or exclamation points or question marks, right? So there won't be letters. Now this is where we do our reassignment and comparisons, okay? So now that we are at a space, so let's say like okay? This is the sentence. So let's say we loop through this whole thing and we put hello in current word. Now we're at this space, right? We're at here, right? So now we want to say, what do we want to check? What's the thing we want to check? What is the most important thing of this function? What is the goal? Most vowels, right? So, how do we know how many vowels are in here? If we're at this space, this first space, how do we know how many vowels are in hello? It's a number and I put it somewhere, right? In current count, right? And does everyone agree that current word at this point in time would be hello? So current word is hello and current count is 0. So what am I going to check? Max vowels, right? Because we don't really care about the words themselves. We just want to know how many vowels are in them. So we can say another if statement in here. If max count is less than current count. If max count is less than current count, we're going to do max count is now going to be equal to current count. But that's not the only thing we're doing, because we're not actually returning the number of vowels at the end of the function. We need to actually keep track of the word. So we will say max word is now going to be equal to current word. Fuck. Right? And regardless if this if statement is true, doesn't matter. Because the next thing, just let me finish. When I is increased, we're going to be at a different word, right? Like logically, looking at this sentence, right? So even if the previous word did not have more vowels, so we put this outside of the if statement, we want to reset current count to 0 and current word to an empty string. Even if this is not true. This if statement is just if we found a word that had more vowels than our max count variable. Then, outside of the for loop, we can return max word. So down here, if we run most vowels and we throw example in there, well, console.log what this is, we at least because of the period, that's my bad. We get Listenek. And if we add 3 E's to over here, well, not 3 E's, but now we have that. And we have this, and we have hello. Right? Any questions? That problem is annoying. And there's a lot of things going on. You have to check multiple things. You have to keep track of multiple numbers and words, you know? And doing that is annoying. But you understand the logic behind how you solve the problem, right? You find the breakpoint between the word, you check the word you just went through to see how many vowels are in there, and if it's greater than the amount that was already stored in the max count. If that is true, then our max count is a new number, and the max word is a new word. And we initialize all of these things at 0 because we know if we ever get at least 1, that will be greater than 0. Any questions? Did I confuse you guys even more than you were before? A little bit? You guys okay? Loops are tricky. Solving problems, knowing how to start solving problems is like tricky. It's, I don't expect any of you guys to be good at that right away. So don't panic if you having trouble like starting a problem, okay? That's kind of the hardest part. Always starting to code is the hardest part. Once you get in the flow of things, once you recognize certain patterns and certain questions, you guys will be okay, all right? I promise. And loops are extremely powerful tools. So you will be using loops throughout every workshop until you're done, okay? Loops are pretty much involved in everything. Any question before I go into today's topic?
Do you use loops in real work a lot?
Yeah. Yeah.
Actually, I have a question. What kind of coding do you do? I don't mean to deviate, but what kind of developer are you?
Oh, I'm a front-end engineer. Yeah, so I work with I work in React, and JavaScript and stuff, and on the cloud, AWS cloud. Yeah, it's all right. It's pretty fun. All right. So now we will talk about coercion. What is coercion? Oh yeah, and we're also going to talk about Truthiness. If you remember when I was talking Monday, I said the word truthy a lot. And all of you are probably thinking, what the hell does that even mean? What is that? Before I can tell you what that means, we have to talk about coercion. When I say coercion, I mean type coercion. You guys know that there are different types in JavaScript, right? You got numbers, you got strings. What else you got? Booleans, null, undefined, right? There's a lot. So, what if I told you that there are methods in JavaScript that you can actually make these values into different values, right? And there are two different categories of this called implicit and explicit coercion. Okay? I can't remember which one is. Yes. Okay. So explicit coercion. You don't really have to remember the explicit part, but this is saying that I, as a developer, see this value, and I am choosing to change this into something else. And there's many ways to do this. So let's say I have, let number equal 5. Cool, right? Let's say I wanted to make that a string. So I would just console log string 5. Capital string 5. You still get a number, or is it? The way to check an actual type, you say type of space and then something, okay? And you see that this is actually a string. This capital string is the global string object. There are a lot of global objects with different built-in methods off of their prototype, don't worry about that you can use in JavaScript. Using the string prototype like this will coerce anything inside of it into a string. It coerces this number into a string. The same can be said for the global number object. This is actually a number now. What if I try to coerce undefined? Really? No, what about no? Wait, what? Oh, shit. Wait, hold on. That shouldn't be doing that. Oh, that's my bad. So it's still the number, but what it actually is NaN. NaN stands for not a number. Not a number's type is actually number, and that doesn't make any sense. You can see it just confused me, because I had no idea what was going on. Not a number's type is actually number, but not a number is actually not even an actual type, right? It's sort of like a JavaScript error. It's like a really, you never want this ever, okay? It's saying you're trying to coerce something into a number that in no possible way could be a number. Like a string that says null in it, right? Not a number is weird. Not a number is not even equal to itself. Okay? It's a very weird thing. But its type of is a number. So that's explicit coercion, what I'm doing right here, right? I'm doing capital string and capital number, global string and number objects, invoking it like if it were a function, maybe it is a function, and putting something inside and expecting the result to be of a different type, right? That is explicit. I'm telling the program to do this. I'm writing this myself. That's explicit, but what about implicit. Sometimes JavaScript is just going to coerce things behind the scenes without you even knowing. This could be very, very helpful, okay? This is great sometimes. I love it. But you have to be aware of what's actually happening, or it can cause a lot of bugs in your code. What do you guys think? What do you think this is? It's 55. Oh wait, let me comment these concepts out. It's 55. JavaScript says that whenever you try to add something with a string, whatever the type of the other thing is, it will be coerced into a string. Okay? I did 3 things in a row here. 3 additions, right? I did 5. Oh, wait, what the hell am I doing? Jesus Christ. I did 5 plus 50. Like order of operations, it goes from left to right. So 5 plus 50 happens first. The result of this operation is 55 plus a string 5. You get, this is actually a string of 555. Does everyone understand? A quick way to coerce something into a number like this is to just go like that. If I did type of that, it would be a number. That is shorthand for explicitly coercing something into a number. Same thing can be said with this, but not this. If you add anything to an empty string, basically you put whatever that thing was into that empty string. So this is a very quick way to coerce something into a string. Okay?
Anytime a string is first, all the numbers after it become strings, correct?
Anytime a string is first, yes. If a string is last, and you add 10 numbers before that, those numbers are actually added together, but the sum of those numbers will be in a string form, not a number, if the string is at the end. So, that's implicit coercion. Well, a little intro to implicit coercion, because the real thing, the real scary part about implicit coercion happens with double equals, okay? 5 double equals string 5 returns true, okay? This, there's no reason for you guys to be using a double equal sign, okay? A double equal sign ignores type. It coerces things behind the scenes, okay? And these things, so always use triple equal, okay? Because that takes type into account. 5 is not equal to a string 5. It doesn't make any sense. Those are 2 different values, right? This can get really wonky too. If I did empty string double equals null, oh no, it was something weird, I can't remember. Yeah, an empty string double equals 0 is true. No, it's not, you know? It doesn't make any sense. Because behind the scenes, I don't even know what's going on here.
Isn't that a Boolean, so it's going to return true false? You're not doing the math operator.
Yeah, but it's saying these are true.
Yeah. Well, a null and a 0.
Well, these are 2 different values. You know? So the reason why a double equals is true is because one of these things, maybe both of these things are being coerced behind the scenes, right? There's no reason to ever use double equals, okay? That's what I'm getting at. You rarely need to check and see if things are equal if they can be coerced into the same type, okay? You will rarely ever need to do that. So just use triple equals, okay? Say, I will use triple equals. Thank you. All right. So, now that we know about this coercion stuff, I'm just going to quickly talk about truthiness and then talk about some logical operators. So when I say truthiness and falsiness, I'm not talking about the Boolean values true and false. When I say something is truthy, I mean if you were to coerce this value into a Boolean, it would be true. When I say falsy, I mean if I were to coerce this value into a Boolean, it would be false. Okay? What do I mean by that? If I console.log capital Boolean, the global Boolean object, A, and I said hello, I get true. Because any string with length is truthy. If you coerce any string with length, you get true. And coerce it into a Boolean, you get true. An empty string is falsy. There are a lot more truthy values than falsy values in JavaScript. Some falsy values include null, undefined, empty string, and 0. Okay? I think that's it. If I'm missing something, it'll come up. But that's what I mean by truthy. All this time that we do if statements, like you can write if true console.log hello, right? Wait, hold on. Right? If true, console.log hello. If 55, console.log hello. Hello still runs. Because the if statement actually coerces this into true or false. It looks at truthiness and not if the value is true or not. Does that make sense? It doesn't look at the value. It looks and sees if the value, well, it does. It looks and sees if the value is truthy. Okay? Does that make sense? Like if statements, you can pass in any value to that, right? It doesn't have to equal true or false, right? Usually when you guys write if statements, you say if the current character is equal to 0, you know? Like then you would do something. Because if it's equal to that, you get true or false. But you can actually put in whatever you want. A number, any number is truthy except 0. Okay? So, this if statements actually check truthiness rather than the value of the Boolean, true or false, right? It checks for truthiness. It doesn't have to like be an expression that equals the value true or the value false. Does that make sense? Yeah.
So if we write 0, it's just not going to print anything.
100%. Ignore the undefined. But what's it called? The other falsy value is false. I always forget that one.
Not a number.
I don't even, is that even considered a value?
I just looked it up.
Oh, yeah? Oh. All right. Yeah, okay,
Oh
cool.
no, except not a number. Maybe it's not a false.
No, it is false. Yeah, I mean, you can coerce it into I don't know, whatever. Not a number's weird. It's like, you never use it for anything. But it exists, okay? So, before we get into the slides, I'm just going to quickly show you logical operators, okay? These logical operators are and or, okay? What do you think this is going to be? No. And what? Well, I don't know why you would know. I don't know why I asked you this. Why would anybody know this? And I have to console log. And returns the first falsy thing it finds. And returns the last truthy thing if it does not find a falsy value. And is a very powerful tool you can use. A good place to think about using them is inside if statements, right? If you want to check more than one thing, if you want to check more than one equation is true, right? If you want to check if this is equal to this and this is not equal to this. If both of those things are true, then the if statement will run because the and thing returns the last truthy value. But it returns the first falsy value it finds. So, like I said in the if statement example, if one of those expressions equivalates to false, it returns false. So the if statement is now looking at false. Does that make sense? Likewise, what is that going to be? If what I said and returns the first falsy thing and the last truthy thing, what do you think or returns? Or return, yeah.
Meaning whether it returns true or false?
It doesn't return actual values true and false, but it does return the first truthy thing that it finds. Oh, I have to console. You get 6. Think about it in an if statement. If all of these, at least one of them needs to be true, right? At least one of these things needs to be true. This, or this, or this, or this. When it finds the first truthy thing, oh, this is true, just return that. That's what or does. Or goes through everything, all of these, and looks for a truthy thing. In this case, this is, you can't see an empty string in the console. In this case, it returns the null, right? And you know it's the last thing because it goes through all of them and it looks for the first truthy thing to return. Yeah. Huh? Null is falsy. But if there's nothing truthy, it returns the last falsy thing. And if you recall, I said that these are logical operators, right? So, this is valid. These are all operations. Like you can do 8 plus 10 plus 50 plus 100. You're just adding things together, right? You're performing operations in a row. This is the same thing. Okay? Yeah.
If you have the or statement in an if statement, is it technically returning anything, or is it just allowing you to go into the if statement if it's true?
The OR operator returns something.
Okay.
And the reason I know that is because I'm console logging these variables. These variables hold values, 0 and null. Null was returned by this statement.
But if it was an if statement, you wouldn't necessarily need the false.
You wouldn't need the
ID,
thing
but
that
it
it's
would be
returning.
Available to
Yeah, you wouldn't
access it.
you wouldn't need the thing that it's returning in an if statement in a conditional like condition, right?
Yeah.
You would just need to know if that's truthy or falsy. But you know that that OR returns the first truthy thing, right? And or the last falsy thing. And otherwise returns the first falsy thing or the last truthy thing. So since it returns the first falsy thing and it has to go through everything, make sure everything is true, and the last thing, if that's true or not, it doesn't matter. If the last thing was false, it would return that as well, because that would be the first falsy thing, right? And since that value, that falsy thing, is being returned, the if statement will be looking at that falsy thing, okay? So these operators return something. So now I'm going to go into the slides, okay? And I'm just going to talk about coercion again. And you're going to hear everything I just said again, okay? Coercion is like tricky, and it's like more about the language of JavaScript. And it's just something you need to be aware of and know about. Truthiness is, truthiness I think is easy to grasp. Just know the falsy values, just remember them. 0, false, empty string, null, undefined, So yeah, in the slides we'll talk about types, explicit coercion, implicit coercion, concatenation, loose equality, coercion to booleans, which is truthiness, which values are truthy, falsy, conditional expressions. Oh, I forgot about the bang operator, and then logical operators. Don't worry, the bang operator is super useful. So types you've already seen. You've seen numbers, strings, and booleans. These are all primitive types. Other primitive types is null, undefined, and symbols. Symbols are not covered in this course. Don't worry about it. I don't use symbols during my work life, so that just goes to show you don't really need to worry about them, okay? So you have complex or object types as well, like functions, arrays, which we'll cover next week, and objects, which we will also cover next week. Major differences between primitive and complex types. Only complex types can be mutated. We will cover this next week. This is just sort of like an intro, just a little intro, yeah? Primitive types are passed by value, and complex types are passed by reference. We will cover this later as well, okay? Don't worry about it now. So coercion occurs when the type of a value is changed to a new type. You coerce one thing into a different type, okay? Explicit coercion happens when we use one of the built-in global objects to create a value of a new type. So we say let num equal to 10, and we console log type of num. We got number, right? Then we say let string, we're going to set that equal to the global string object invoked, and we pass in num. That's the string global object, right? Then we console.log string. It still looks like 10 in the terminal, but its type is actually string. Any questions on this? This is pretty straightforward, right? Right? Okay. So coercion occurs when the type of value is changed to a new type. Yeah, same thing. As you can see, we have the string of 1,000, the string of character 1000. Its type of is a string, but we can change it into a number. It looks the same, but its type is actually a number. Cool, right? Implicit coercion also changes the type of a value, but unlike explicit coercion, Implicit coercion is something that JavaScript does for us behind the scenes, okay? This behavior can be helpful. I think it's very helpful, but it's important to understand how it works so we anticipate what our code will be doing, okay? So when we do 10 plus 20, we get 30, right? No news there. When we do a string of 10 plus a string of 20, we get a string of 1020, right? It's just adding a string together. But if we do 10 plus a string 20, we get this. It looks like this, and it is that, because it coerces that 10 into an actual string. The plus operator will implicitly coerce a number to a string if you try to add it to a string. As you can see, a string of 10 plus a number 20, 30, 40, 50, you get 10, 20, 30, 40, 50. And it's a string. Does this make sense? Cool. Let me know if I'm going too fast or you have any questions. This is pretty much the same thing, except the string is at the end. That means order of operations. 10 plus 20 is, plus 30 is, plus 40 is, plus the string 50, you get 10050 in a string, right? This makes sense. To me, this makes logical sense. Does this make logical sense to you? Right? If it doesn't, it's okay. But this is how it is, okay? Yeah. What do you mean math?
So like 10, 20, 30, 40, string 50. What if you had like plus 60, not a string, right after that? Would it return 100, 50, 60? Or
Yes.
it won't add the maths on the end of the maths?
This is what's actually happening. It's JavaScript runs through this, it sees the 10, and it sees the plus, and then it sees the 20. It doesn't know what this is, so it computes. This is now 30. Then you see another plus, and then a 30. It doesn't know what this is, so it computes, and you get 60. Same thing happens here, you get 100. Then you have the 100 plus the string 50, right? Then you get a string of 150, because it 100 and then 10050, right? It does this like one at a time. So now that we have this value and we have a number 60, the string of 10050 plus a number 60 would be that same string with 6 and 0 at the end of it, right?
So it stops being math when it gets that first string and they all get a string.
You could say that, yes.
Sorry.
No, it's cool. It goes left to right. Cool. So avoid using the double equal operator. Right? Don't use that operator, because it uses a large set of rules to implicitly coerce values to the same type before it compares them. So 10 double equals 10, that is true, and that makes sense. 10 double equals to a string 10, that's true. That also kind of does make sense, but not really. String true is double equal to true. This is false, which is kind of weird. If this is true, why is that not true, right? It's kind of weird. Empty string is double equals to false. That's true. That's kind of weird, right? True double equals a string 1. That's the weirdest one, right? Behind the scenes, JavaScript actually coerced these values to numbers. True coerced to 1, and a string 1 coerced to 1, so 1 is double equal to 1, which returns true. That's that one. If you coerce, I think if you coerce true and false, it'd be 0 and 1. Okay? The point is, don't use double equals. It's just like some crazy stuff happens behind the scenes that you don't even really want to know about. In no way would you ever want this to be the case, okay? You know? So values can be coerced to Boolean values too. So this is true. The string, I am a string, coerced to a Boolean is true because any string with length is truthy. So that means if you coerce any string with a length, you would get true. When coercing a value to a Boolean, JavaScript uses rules to decide if a value should be coerced to true or false. Values coerced to true are called truthy, while values coerced to false are called falsy. Right? That makes sense, right? It's not actually talking about the value of true and the value of false when I talk about truthy and falsy. When I say this value is truthy, I say if it were coerced to a Boolean, it would be true. But that doesn't mean that it is true, right? Right? It's the what if, you know? Most values are truthy. Strings with length, any non-zero number, all arrays are truthy. This is what an array looks like. All objects are truthy. That's what an object looks like. They all coerced into a Boolean would be true, okay? These are the only falsy values, not a number. So coercing an empty string, 0, null, undefined, and not a number, you get false, okay? That kind of makes sense, right? Does anyone have any questions so far? All right. Recall how a conditional expression works in an if statement. If the expression below evaluates to true, then the if block will run. If 5, console.log in the if, else console.log in the else. If 5. That sounds weird, right? But what it's actually doing is it's coercing that thing into a Boolean. 5 is truthy. It's true. So we go into the if, because any non-zero number is truthy, right? What if the conditional expression evaluates to a non-Boolean value? What's the difference between this? Same thing, right? The string has length, it's a truthy value, okay? Right? Okay. JavaScript will implicitly coerce the result of an expression in a conditional. This is the same thing over and over again, honestly. You see here, though, if 0 is not truthy, right? So you go to the else. The same thing would be true with null, undefined, or an empty string. If those values are ever in an if, it would go into the else automatically because those are not truthy, those are falsy. The bang operator. I forgot to show you guys this. The bang operator, or the not could also be called the not operator, actually coerces whatever value it is in front of into the opposite of its truthiness. Okay? The operator coerces a value to a Boolean value that's opposite of its truthiness. So console log, bang true, bang a string ABC, bang 100, bang an array, bang an object, you get false, okay? It's the opposite. But it's better than writing capital Boolean and then like reversing that somehow, okay? Bang is very powerful. It returns the opposite of its truthiness, okay? And it returns the actual value, okay? You can use double bang to explicitly coerce a value to a Boolean value that reflects its truthiness, not, right? So this gives you what its truthiness actually is. So the bang operator returns it the opposite of its truthiness, and the double bang operator returns its truthiness. You can think of this as shorthand for coercing something into a Boolean. Bang and bang bang, okay? Using bang could get confusing, but it's very powerful because it's quick. Any questions on the exclamation points, the bang operators? No? Yeah.
When would you, I guess, use this?
Well, it's quicker, right? Like, do you want to say, like, if this whole thing is equal to undefined, or equal to null, or equal to 0, or equal to empty string, or you just want to do bang that? Well, bang. Yeah, bang that. Like, instead of saying, like, this is equal to false, you could just do bang. Because that returns the opposite, right? So if it is, like, a falsy thing, then it'll just be true. It's just quicker. Right? Does everyone agree? How you guys feeling? It's okay? Yeah. Logical operators also coerce values to Boolean values. If 10 and 10 and 20, console.log, both 10 and 20 are truthy values. Hey, that's what we get, right? If you put the and in the if statement, both things on either side have to be truthy. If there are like 7 ands in a row, everything has to be a truthy value to get into that if statement. If one thing is falsy, it goes to the else. Why is that? What did I say and returns? The first false value, or the last truthy value, right? So that's why, since this it actually returns the 0, so the if statement is actually just looking at 0. If 0. No, not if 0. Else, right? Does that make sense? Cool. And returns the first falsy value or the last value if all are truthy. The return value of 10 and in apples and in 0 and in null. Return value 2, lucky and in number and in 7. You get 0 because that's the first falsy value, and then you get 7 because that's the last truthy value, right? Does everyone agree with this? Is this confusing at all? Yes? That's okay. If you line up a bunch of values and you put an and in between all of them, JavaScript will go through all of those values until it finds a falsy thing. Once it finds the falsy thing, it returns that value. It returns the actual value. If it never finds that, if it never finds a falsy value and everything is truthy, it returns the last value. If you want to, this is not happening, but if you want to, you can think of it as looping through all of these values and returning either the last thing or the first falsy thing it finds, okay? The last truthy thing or the first false thing. It's not actually looping through anything, though, okay? Or returns the first truthy value or the last value if all are falsy. So, null or undefined or happy or pumpkin, you get happy. It returns the first truthy thing. Or it returns the last falsy thing, if nothing is truthy. False, null, 10 is less than 0, returns false. And not a number, you get not a number. It's the opposite of and. When you use this in an if statement, you have a string of ors, only one of those things has to be a truthy value. Right? Cool. So we talked about coercion, explicit and implicit. We talked about truthiness, the bang operator, conditional expressions, and logical operators. Any quick questions before you guys take like a 5-minute break and start the workshop? Any questions? You guys sure? All right. I'll slack out pairs in 5 minutes, okay?